Hi, everyone, and welcome back for the Lab 13 lecture video. This week, we're going to be working on sheet metal tools and creating a flat pattern, which is what a manufacturer would use to laser cut out the material that they need and then bend it into the correct shape for whatever product they are manufacturing. So I'm going to go ahead and share my screen, and we'll go ahead and get started. So the first thing that we're going to do is open up a new part file and make sure that we are in IPS inch pound second because we are going to be drafting in inches today. So let's go ahead and actually first things first, when I first introduced SolidWorks, I talked about the tabs that have different menus for different types of tools. So up until now, inside of a part, we have only used the Features tab, which is to create the 3D elements, and the Sketch tab, which is to create the generally 2D elements, unless we're working with a 3D sketch for some reason. I did touch base briefly on the surfaces and the sheet metal, which we're going to need sheet metal for this lab, and we're going to need surfaces when you do lab 14. So if you haven't already, go ahead and click one of the tabs, Features or Sketch, whichever one, and click on tabs, hover over tabs. It'll bring over a number of menus that you can turn on or off, and just go ahead and turn on your sheet metal tab. If you feel like it, go ahead and turn on surfaces too, because you're going to need that when you jump into lab 14. So once you have the sheet metals tab active, this is what we're going to be using a lot today. So we're going to start with our sketch tab, and then for pretty much everything else, we're going to be using the sheet metal tab for a base flange tap, as well as an extruded cut. So let's start with our sketch tab. And on our front plane, we will open a sketch. And starting with our center rectangle, we are going to start our sketch right on the origin as usual. And we're going to go ahead and place that rectangle, and then we can dimension it at 0.75 across the top. And we'll dimension it at 1.7 from top to bottom. Oh. Now, from here, instead of using our extruded boss base, we're going to go over to our sheet metal tab and use this base flange tap. And that is how we're going to get our extrude. So the difference between those two tools is the base flange tap actually will assign a sheet metal value and sheet metal thickness parameter to our material. So right now, we're going to keep it at 0.125. If yours is not 0.2125, if it's defaulting to 0.1 or 0.3, go ahead and change this parameter to 0.125. And extruding forwards or backwards in this case doesn't matter. It doesn't allow you in the sheet metal tool to extrude from the mid plane. So I'm going to extrude mine back towards the back of the part. And this bend allowance here, we're not really going to go into this for our class, but a very brief high-level overview of what this is asking for. This is the parameter that SolidWorks actually will use to calculate the flat pattern. Because when you're bending sheet metal, when you start with a flat piece of sheet metal, hypothetically, if you have a 2x2 square of sheet metal and you bend it right in the center, so if you just do a 90-degree bend right at the 1 inch mark, right in the dead center, the formed part is actually going to be more like something like 0.98 is going to be one flange, and 0.98 is going to be the other flange. So you're actually going to lose material, or seem to lose material in the bent part. And that's because when you bend sheet metal, the sheet metal will compress at the inside of the bend, and it will stretch on the outside of the bend. So if we start with a 2x2 square and we bend at 1 inch, we'll see the formed part is actually going to be something like 0.98 on one flange and 0.98 on the other flange. And that's because on the inside radius, it compresses the metal. And on the outside radius, it will stretch the metal. So what this setting does is it will either use K factor or bend allowance or bend deduction in order to, or you can do custom bend calculations or bend tables if you have a bend table. However, the only way to create a bend table is to actually form a bunch of parts with a known material and thickness at different bend radiuses. So 90 degrees, 15 degrees, 30, 45, 60, that kind of thing. And take physical measurements and then run a series of calculations. And then that will give you the values for K factor, bend deduction, and bend allowance. It's actually a pretty interesting process. And right now I'm actually working on a set of custom bend tables for a manufacturing client. And it's been a very interesting process and project so far. However, without going into any other real complicated detail, we are going to use K factor, which essentially is a factor of the area inside the thickness. So like we talked about, on the inside of the bend, it's going to be less than the original 2 inches that we started with. On the outside, because it stretches on the outside radius, it's going to be longer than the 2 inches that we started with. So somewhere in the middle of that material is going to still be 2 inches all the way down through the part. So those are the values that we're going to assign. Don't worry about this auto relief. That has to do with how it is for specific types of bends in the middle of a part. This relief will allow for different tolerances when working with CNC machines. So let's go ahead and click the green check mark. And you'll see we now have a 0.125 thick by 0.75 by 1.7 inch piece of metal. And from here, we're going to stay with our sheet metal tab and we're going to click edge flange. And once the edge flange tool opens, we can select the top front line, top front edge of the part or corner, and just bring that out. And then let's go ahead. So once that's what we're just going to kind of hover over here and click once, it's going to place it. And then let's go ahead and select the bottom front edge as well, or corner. Just like that. It'll just extend out to match the front. You're going to see this preview. And before we do anything else, let's make sure we have a 90-degree bend. If you change that, for example, if we did 45 degrees, you will see that our bend is going to change. But right now, we're going to do 90-degree bends. It doesn't matter. The length doesn't matter. If you were going to give it an exact length, you have different options on how it's going to calculate those lengths. And it gives you a preview. So this center one right here, for example, is only measuring from the end face here to where the tangent edge, so this is like this tangent edge preview that we have seen in many parts before. It's going to give you that flat length. That's what you're dimensioning here. Let's just go ahead and keep it on this first option, which is dimensioning it from the back to the front. It really doesn't matter though, however, for our case, because we're going to edit that manually. And then our flange position, I'm going to do a Control-4 to give you a side view here. So we can see this first option, material inside, is going to say, okay, so you started with a 1.7-inch tall piece of material. So we're going to maintain that 1.7-inch dimension. So the bend is going to be on the inside and maintain 1.7 inches from top to bottom. This right here, which is the only other one we're really going to go into, is material outside. So it's going to maintain that 1.7-inch dimension from the inside to the inside of this bracket. Let's go ahead and maintain that right there. And with those values set, the only other thing we need to change is the default radius. And for our cases, and this is very, very small and would not necessarily be used in the real world, but we're going to make this bend radius 0.029 inches. At least would generally not be used with an 1/8 inch thick sheet of metal. You're not going to be able to get a 0.029 inch internal bend radius. So that's this radius right here. More likely would be like maybe 0.3 or an eighth of it. You could do an eighth of an inch. It depends on the actual what's called the die of the press brake, the piece that's actually coming down and bending the metal. So with those values set, we're going to go ahead and click the green check mark. Click Control 7, and we can see we are starting to have some semblance of what the drawing is showing us, what our assignment drawing is showing us. Now, just like any other feature, we can come in and edit the feature. However, instead of editing the main feature, we're going to drill in, and we can see, so we've got some information here. This is just holding the sheet metal and bend value information for each individual bend, because we made 2 bends with 1 feature. So each of the bends have information that the software is storing for us. And they also have associated sketches that have been created for us, which we can edit. So I'm going to click on sketch 10. I'm going to edit that sketch. And it will bring us to a very familiar edit sketch screen. And I'm going to click Control 5 just to kind of center it how I have done this before. And what I'm going to do is just go ahead and delete all of that geometry. So now what we have is a blank sketch. However, we have all that bend information saved, so we have a blank slate to start from. So first thing I'm going to do is I'm going to select this horizontal line, the front of the part, and I'm going to convert. So now we have the front of the part. We have our sketch started here. And then looking at our assignment drawing, we can see we have 2 concentric circles out here because we have a hole in our flange. Something just like that. So I'm going to start the first circle anywhere, kind of in this general area. And then the second circle, I'm going to start right in the center of the first one. And let's go ahead and smart dimension and add a diameter to the first one of 0.19. And then we will add a radius to the second circle, the larger circle now. And however, it's asking for a diameter. So there's a couple ways we could do this, as you should already know, but we know that a radius is just half of a diameter. So we need a 0.2 radius. So we really need a 0.4 diameter. So it's easy as that. And if we want to check ourselves, we could just right click that dimension and click the display as radius button. And there we go, just like that. And if you want to remove this, it doesn't really matter for our modeling purposes here, but if you don't like it extending all the way to the center point, you could just, with our radius selected, we can go into leaders and select this little option right here, open leader. And there we go. So now we have a couple other dimensions we got to place from the center of those circles to the origin. Let's drag it straight down, and we're going to put that dimension at 0.62 inches. Enter. And then we're going to dimension vertically to the origin. And that's going to be our 1.9 inch dimension. Now, if you had chosen to extrude towards the front for some reason, instead of following me and extruding towards the back, you're going to have to adjust these values because or dimension from this front face, because the origin, if you extrude it towards the front, is going to be at the back of your part. So just keep that in mind, because when you dimension, if you do it incorrectly, the dimensions aren't going to work out for you when you plot this on the page. So with that, let's grab our line tool. And I'm going to start a line right on this point here. I'm going to just draw a long line all the way kind of out somewhere in this direction. Click escape once. You can click L. That will bring you back into the line tool if you want. Or you can just click up here, click on the line, drag another line kind of way out this direction. Just like that. We're drawing them so long because when we add our tangent relationship here, we're going to have to trim. And it's just easier to trim a long line. So we're going to make those tangent just like that. I'm going to make this tangent to the circle on the other side. Oop, there we go. And then we can grab or click the green check mark, grab our trim tool, and just trim off the excess. And we are also going to trim off the inside of that larger circle, but keep the smaller circle where it is, because that's going to be a hole when we go back out of this sketch and rebuild our bend. So with that, let's go ahead and click exit sketch. It'll think for a second, and then it should rebuild just like this. Now what we can do is go into sketch 11, edit the sketch. And what we have is exactly the same situation. So this time I'm going to delete these, excuse me. This time I'm just going to delete this bottom line. And another way we can do this is actually edit the existing sketch geometry. So right now these are vertical. So let's go ahead and just delete those vertical relationships. Now we can kind of drag these out just like that. And let's go ahead and just do the exact same thing. So let's grab our circles, make 2 concentric circles. Smart dimension those. So we have a 0.19 inch diameter. And then we have a 0.4 inch diameter for a radius of 0.2. 0.4. And then we can go ahead and dimension from the origin, just like we did. And that's going to be the 0.62. And the vertical dimension is 0.19. This is actually 1.9. Let's go ahead, double click that dimension, 1.9. It's going to look a little more correct. And then let's add our tangent relations, just like we did the first time. There we go. And we got one more. Tangent, click the green check mark, and then we'll go ahead and trim what it is we don't need. Just like that, and click the green check mark. Exit the sketch. And with any luck, you should have your edge flange, both of your edge flanges, with the correct geometry now for your part. If you get an error message, try rebuilding. Try just clicking up here at this little rebuild button, or maybe going in, edit the sketch, and then close it. If you know for a fact that your sketch is correct and it's fully constrained all the way around, just try to edit the sketch and then go back out and click the rebuild button again. Sometimes the sheet metal tools can be a little bit finicky, but if you play around with it for just a little bit and you know that your sketches are correct, it will clear those errors. And with that, we are ready to make our final cut. So let's just click on the inside face, the front face of this part, click on sketch, and let's go ahead and draw a circle. Kind of right in this area here. And now I'm going to make that, I'm going to select the origin and I'm going to select that circle center. And I'm going to make those vertical. And then from this top line, not the tangent line here, from this top line to the circle, I'm going to dimension that at 0.35. Just like that. And then the diameter of that circle is going to be 1/4 of an inch. And click the green check mark. And now we have grab our circle tool. And let's go ahead and create a circle. Don't put a diameter on it or anything like that yet. Click on that circle. So this is another way that we can add a radius. So we can add a radius here if we wanted to do that. So we could say, maybe make this a 1-inch radius. There we go. Click the green check mark. Now let's use our line tool, create a center line from the center of this circle here out to the perimeter of the circle that we just drew, which, by the way, also has its center point at the center of this dimension, fully defined circle here. Now let's grab another center line, just like this. And we're going to make those two lines equal. And you got to make sure that they have these relationships so that this endpoint is coincident with the perimeter of the circle. So let's take those, make those equal to each other, which they will be anyways because they are on the same radius. Let's go ahead and dimension them, give them an angular dimension of 14.48 inches. Just like that. Now let's grab another center line. We can zoom in here a little bit, and from point to point, just like that, grab your point tool and make this coincide with the midpoint, and it should have a midpoint indicator here. Otherwise, it's not, the relationship has not been added. And now from the center of this circle to this midpoint here that we just added, let's highlight both of those and then make them vertical to each other. Just like that. And from here, we can go ahead and trim our circle. And then now we can delete this little arc, or you can trim it. I'm just going to delete it. Just like that. Now, this is not fully defined. So what we have to do here now, let's just go ahead from that line to this point. Let's just go ahead and give that a dimension. So that's going to be 0.98. Remember, because our radius here was 1 inch. So this is going to be a little bit smaller than that because it's not quite at the radius of that circle. So there we go. However, these lines are exactly 1 inch. Click OK. Now let's grab our circle tool We're gonna make 2 circles, one at the end of each of those points. Now let's make those circles equal to each other. So select both of the circles, make them equal to each other. And then I'm gonna select one of those circles and make it equal to this 0.25 inch fully defined circle. And there we go. Now we can grab our circle tool here from the center of this circle and give it a tangent relationship to both the top and another circle tangent relationship to the bottom, just like that. Grab our trim tool and we can trim off what we don't need, just like this. And then you got to be careful because we do have some stragglers in here. Make sure those are trimmed. And then I didn't this time, but you may have another little straggler right in here, depending on where you ended up trimming first. But in our case, right here, we have both our closed profiles, single individual closed profiles here. However, you will see that I am not fully defined. So what we can do, we can go ahead and add additional dimensions, or in our purposes, we know that this is the correct dimension. So we would have to give radius dimensions. We already have the equal relationship here, but to do this nice and quick, underneath display delete relations. Oh, actually, we gotta get out of our trim tool first. And underneath display delete relations, we can click fully defined sketch. And go ahead, all entities in sketch should be selected, and then click calculate. Then it will give you a little preview, and we're gonna click the green check mark. And there we go. So with our sketch fully defined, let's go back to our sheet metal tab, and we're gonna click extruded cut. And give that a second to load. And we're gonna say through all or up to next. I'm gonna do up to next. I'm more partial to that in these types of situations. And we're gonna click the green check mark. Now with that, we have our sheet metal part fully formed. However, you'll notice in the sheet metal tab, we don't have an option to flatten it. However, we do have a flat pattern in our feature tree. It just by default is rolled back. So if we just grab this little blue line and drop it underneath our flat pattern, now it's still suppressed here. So it's kind of, it's not bolded like these other ones are here. We can now have the option to flatten our part. We're gonna go ahead and click flatten. Click Control-1 to get a front view. And there you have it. Now we have the ability to flatten and form our part. That, make sure to save it in your Lab 13 submissions folder if you haven't done so already. And from here, let's go File and Make Drawing from Part. CAD 154 title block. And then go ahead and add your front view, just like that. And click Escape. Now, from here, we can add a section view. So we've already done this before in the Drawing tab. We can click Section View, and it will give us an option to place a section view wherever we want. So we can go ahead and do something like that. However, what I would like you to do is grab your line tool and start right in the center of this circle. So you kind of hover over that and then drag, like hover over way out to the left and click when you get kind of farther out, and then click maybe somewhere right around here, just like that. So now we are going to create a custom section view, and you could do this any number of ways. So you can do something like this and create a section view on what creates this plane here from either direction. But we're not going to do that right now. We're going to click the line that we just drew, And then in the drawing toolbar, click section view. And now we have our custom section view, just like that. And this, we're going to flip the direction. Oh, excuse me. No, we're not. If it's this view here is flipped so that the circles are up top, go ahead and flip the direction. And I have already created a section view earlier. So mine started at C. I'm just going to override that right here as A and click the green check mark. Another benefit of drawing your own line is that it gives you the ability to place where your A's are, because otherwise you're not able to just drag these out. You used to be able to, however, it doesn't allow you to do that anymore. So that's the main reason that I drew my own line farther out. And as usual, I'm just going to go ahead and edit this, double click on that text. And I'm going to make all of that text the same size. So let's see what 12 looks like. And that looks good to me. And I'm going to drag that up and just like that. And from here, I'm just going to kind of space this out a little bit more. And we can adjust our section text again as needed, just like that. And let's go ahead and add some dimensions. Grab our Smart Dimension tool. And let's go here to here. Just go straight up. Go from our circle to our left edge, kind of bring that straight up. And now our dimensions are kind of big. So let's go in to our little cog up here, our options. And in the document properties, let's go to dimensions. And we can change our font size right here. And let's maybe make that points. Maybe make that 10. Click OK, click OK. And there we go. That looks a little bit better. Grab our Smart Dimension tool again. Just like that. Let's click on this dimension and give that a precision of 3 decimal places. Okay. Smart Dimension tool from center of the circle to this flange, the bottom of this flange. There we go. And we can drag that out farther if we want. We can leave it kind of right where they had it. That's fine. Now center of the circle to the bottom flange here. Just like that. Grab a dimension. And again, for any of these, we can adjust our leaders a little bit. So for here, I'm going to make it a 1 arrow / open leader, just like that. And my custom text position, if I select this middle one, that'll give it so that my text is horizontal. You can also do that for stuff like this, custom text position, and give yourself a bent leader. Now we can also, so we can smart dimension this the same exact way, or we could just come in here like this, double click on our text. Actually, you don't have to double, you can just click, and then in your dimension text here, just after the end, the little caret, in space and TYP, just like that. Make sure it's all caps. And to get this angular dimension here, what we're actually going to have to do is go into your sketch and grab a center line. And from the center of this circle to the center of these circles, draw center lines. Just like that. And if we really want to too, we can grab our circle tool, just like this, trim off what we don't need, which is basically the entire circle other than this little radius right here. We're going to make that a center line as well for construction. There we go. And now we can grab our smart dimension tool and dimension between these two lines. And that is how we can get our 14.48 degree dimension. And let's go ahead and just make this dimension driven, because it is being driven by the fact that these two lines are already constrained. Now we can grab our radius tool again, and this radius, which would be important for a manufacturer, oh, it looks like it's 0.99 and it should be 1 inch. So what we can do here, yes, make it driven. Let's go ahead and position this how we want, and then we can go look back at our model to make sure that it's drawn correctly. So let's go ahead, go over to leaders, and let's go custom text position, make it horizontal to give ourselves a nice bent leader there. And we can just go ahead and keep it just like that. Now let's go ahead and go back into our part and take a look and see why this is not a full inch like we had it originally. So we're just going to hover back down here, go over to our part file that's open. And let's go into the sketch for the cut extrude, edit sketch. Now we did define this where it was, so I'm just gonna delete that value. Dimension this guy right here, and you gotta take the dimension. You can't. This is just a vertical dimension, so you have to make sure it's aligned properly. So there we go. And it looks like as we were kind of messing around with this sketch, we made this a little bit less than the 1 inch radius. So let's go ahead and just make that 1, just like that. Now our center point is still aligned with the midpoint here. So that's the only change that we have to make. Our sketch is still fully defined. Go ahead and exit the sketch. Control S to save it. We can go back to our drawing file. And there we have it. We have a radius of 1 inch. And there we go. So let's just throw a couple more dimensions on this, and then we'll add our flat pattern. So we have a 1.9 inch here from that front face to our hole. We have 0.62 from our origin. You might have to play around with it a little bit. There we go. We have a 0.19 inch dimension from our through hole. And we have a 0.2 inch radius. Now let's just go ahead. I'm going to select both of these, give them their custom text positions under the leaders selection area, just like that. And then actually, I'm going to highlight both of those again. Go into leaders and give those open leaders like that. And it looks like we have automatically accidentally changed our 0.2 inch radius to a diameter. So let's just right click, display as radius. And there we go. So almost done here. Let's go into drawing, model view. Grab your lab 13. We are going to show this as a flat pattern. Drop that in like that. Click escape to get out so you're not putting projections in. So there we go. So now we have our flat pattern. If your bend notes are not showing up, you can right click on the flat pattern, go into properties, and just make sure display sheet metal bend notes is selected. We're gonna go ahead and click OK. No dimensions there, that's just fine. And last but not least, go ahead and click on our front view here. Click projected view. Drag kind of up and to the left so we get a nice isometric. And then we can drag this over to this area over here, this blank area. Do a shaded with edges, make it high quality, and click the green check mark. And with that, Lab 13 is complete. Go ahead and update or edit your sheet format with the correct information and make sure that Lab 13 all dash your initials is the naming convention. Save it as a PDF, and this is what you will submit to the Lab 13 Dropbox. Thanks for following along, and I'll see you in the next one.